Sets of data can show a relationship or correlation between two variables even when the variables are not related or dependent on each other. Because of this, correlation does not prove causation where a change in one variable causes a change in another variable. Say it with me now. Correlation does not prove causation. Just because you find a correlation between two variables does not mean one of them causes a change in the other one. It is important to determine whether one variable is causing the other to change or if the data just shows correlation. For example, the Little Humane Society tracks the number of dogs and cats that are adopted each month. The table shows their records for 5 months. Graph the ordered pairs to create a scatter plot. Determine whether the scatter plot shows a positive or negative correlation, and determine whether the data shows causation. So the first thing we'll do is we're going to graph these, and I've already got scales going. The blocks are going to go by tens. So number of dogs, January was 90, and number of cats is 124. So I'll go over 90 and up to 124, which places it about right here. 5472 is approximately right here, about in this spot. 6295 is just past the 60 and up to 95, which is just shot or halfway between the 90 and 100, so approximately here. 3953 places it a little bit low down to here. And 85121, halfway between 80 and 90 and up to 121, which is about right here. So we've graphed it, we've done part A. Determine whether the scatter shot flows a positive or negative correlation. I would say this is distinctly positive because as the number of dogs increase, so do the number of cats. Determine whether the data shows causation. Does one variable cause the other? Could other factors be influencing the data results? So what this is asking you is, does the number of dogs adopted cause the number of cats to be adopted also increase? And the answer to that really simply is no. This is not causation. The number of cats or dogs and the number of cats adopted are not directly related. There could be other factors that influence this. For example, just simply better advertising could be the actual underlying reason why as the number of dogs that are adopted increase, so do the number of cats. It could be any number of things, but it is definitely not just because there's a lot of dogs that are being adopted does not mean that there are a lot of cats being adopted. They are not directly related. Once a correlation between variables has been determined, it is important to analyze the situation to determine whether the data also shows causation. So even though correlation does not prove causation, there are cases where the correlation is part of a causation. So determine whether each situation illustrates correlation but not causation, or if it's causation. Rebecca records the pounds of each type of vegetable her garden produces each year. She discovers a negative correlation between pounds of sweet potatoes and the pounds of spinach it produces. So negative correlation means that the more sweet potatoes produced, the less spinach would be produced, and vice versa. If there's more spinach, there's less sweet potatoes. So is this a correlation but not causation, or is this a causation? And this is correlation but not causation. This is correlation but not causation. It is unlikely that just because, spell that correctly, just because more sweet potatoes are being produced does not mean that that is the reason why there's less spinach being produced. It could be any number of things. It could be the soil. Some plants grow better in certain climates than the others. So that's not necessarily, that could be the underlying reason, but it does not mean the sweet potatoes are causing the spinach to not grow. Part B, a local police report states that there's a positive correlation between the number of days it snows and the number of car accidents annually. So that is probably likely a causation. And the reason growing up around here, we know that when it snows that there's a lot of accidents because for some reason people forget that snow is slick and there are just simply more accidents directly related to the snow. 2A, when mixing orange juice from concentrate, there is a negative correlation between the amount of water added and the concentration of orange juice. This is also a causation, because the more water you add to the concentrated orange juice, the less concentrated it's going to be. The water is directly diluting the concentration of orange juice, so this is definitely a causation. Then 2B, Teresa sells crafts at a local flea market every weekend. She noticed a positive correlation between the number of necklaces and the number of toy puppets she sells each day. So is this correlation, or is this definitely a correlation, but is it a causation? So does it mean because she sells more necklaces, she sells more toy puppets? Is selling more necklace, this is the direct relationship to selling toy puppets? And this is correlation, definitely, but it is not causation. And then again, there could be more underlying reasons. Probably the most likely reason is attendance. If there is high attendance at the flea market, it is likely that the attendees are buying both necklaces and toy puppets. So naturally, if there's more people there, she's going to sell more of everything in her booth.